Okay, we are now in the third section of chapter 7. It's 7-3, rational exponents. So we don't have formal notes for this. That's fine. Okay. Rational exponents are exponents that are rational. So 5x squared, what you've been doing, that's a rational number. Any number that can be written as a fraction, an integer over an integer, is a rational exponent. Okay. Let's try it with real numbers instead of x. If I have 25 to the 1/2, that is the same thing as saying 25 to the first with a square root. 25 to the first, square root. We normally don't write the 2, and 25 to the first is 25. So your answer is 5. So this is the same thing as saying the square root. This is the same thing as saying the cube root. So I could say 27 to the first, cube root. So what number times itself gives you 27? That would be 3. So the cube root of 27 is just 3. Okay, so this is where we run into rational and irrational exponents. Okay. So in this chapter, you're going to evaluate and rewrite expressions involving rational exponents, and you're going to solve equations involving expressions with rational exponents. So example 1. This is something you might see. You're going to write each expression in radical form, or if it's in radical form, write in exponential form. So we already did the first one, 25 to the 1/2. This is an exponent form. To write it in a radical form or a square root, you'd write it like this. What if we had 5x to the 1/2? Well, the 1/2 is only being used by x. So it would be x to the first square root, which is just 5 square root x. They're the same thing. They're just saying, hey, are you able to write it in different forms? Yes, you are. So that's taking a rational exponent and making it a radical. Now, what if I have a radical? Could I give it a rational exponent? Well, it's 18 to the first, and then there's a 2. So this is going to be 18 to the 1/2. 18 to the first, half. Square root of 8p is the same thing as saying this whole thing is raised to the first, and this is 2. So it's the same thing. All right. So the first example was just, can you rewrite back and forth in different forms? Yes, you can. Example 2 is called nth roots. So like we said, if I have the cube root of 27, I need a number multiplied how many times? 3 times. What number multiplied 3 times gives you 27? 3 times 3 times 3. So the cube root of 27 is 3. They're saying they're saying 3 times. They're saying what number 3 times? 3. Let's try another one. The 5th root of 32 is what? So they're saying what number times what number times what number times what number 5 times gives you 32. Well, 1, 1, 1, 1, 1 wouldn't. Would 2, 2, 2, 2, 2, 4, 8, 16. Yep, so your answer's 2. Okay, so this was just finding the nth root. N being whatever values here. N represents this value. Okay, and you're going to do some of these practice problems in Delta Math. Let's try a few more. 125 to the 1/3. Well, we know that's 25 and 25 to the first, cube root. Let's break down 125. It's harder to think about it. 125, I know I can divide by 5 because it ends with a 5. So I'm left with 20. Let's see, 5 goes into 12 twice. 2 would come down on a 5. Oh, so 25. Could I keep breaking it down? Yeah, 25 is 5 and 5. If you don't like doing this, use your factor tree. Say cube root of 125, and then make a factor tree. 5, 5, 5. So I need 3, I have 3. Your answer is 5. So what number 3 times gives you 125? 5. Let's try one more. 1296 to the 1/4. That's the same thing as saying 1296 to the first, but it's the 4th root. Well, let's break it down. I know 6 can go in. Okay, and I know another 6 can go in, and I know 36. And I can keep breaking it down. So if you want to make a factor tree, you can, or you can just say the 4th root with all these 6's. I need 4. Your answer is 6. So 6 4 times gives you 1296. Okay. Let's try one that isn't a 1 on top. It's a 2 on top. So that's the cube root of 64 squared. Now, I could do 64 times 64 and get a big fat number, but I know I'm just breaking it down anyway. And I'm going to keep breaking it down. 64 is 8 times 8, 8 times 8. Well, I have 3 8s, but I need 3 more numbers. I can break that 8 into 2, 2, 2. So I could take out an 8 and take out a 2, and my answer is 16. Or what I could do is say, all right, just break it all down. 8 is 2, 2, 2. This 8 is 2, 2, 2. This 8 is 2, 2, 2. And this 8 is 2 times 2 times 2. You need a group of 3. When you take them out and put them beside each other, your answer is 16. And we'll try one more. 36 to the 2/3. (36 squared is 36 times 36, cube root. Well, I know I have to break 36 down. I know 36 is 6 times 6, and so is the other 36. But I know all these 6's are 2 times 3, 2 times 3, 2 times 3, 2 times 3. I need a group of 3. Oh, whoops, I wrote the problem wrong. It's 3 halves. I apologize. Let's try this again. It's 36 to the 3 halves, not 2/3. So what it would be is the square root of 36 cubed, which is, you can always pause the video, okay? 36 times 36 times 36, which is a square root of 6 times 6 times 6 times 6 times 6 times 6. You just need a pair. I don't have to keep even going. I have a 6, take it out. I have a 6, take it out. I have a 6, take it out. 6 times 6 is 36, times 6 is 216 is your answer. Here's the thing. You can just use a calculator, 36 to the 3 halves, to check your answer. But if you have a keystone and you have to share your steps, this is how you would do it. Okay? So we're just going to focus on problems like this. You're going to have a short Delta Math assignment, and that's it. You don't have to hand in your notes for this chapter. Let me know if you have any questions. Zoom meetings are always Tuesday, Wednesdays, and Thursdays. If that conflicts with your schedule, then it is your responsibility to email me a time where we should meet.